trip over myself. All right, testing 1, 2. Are we on? Are we alive? Okay. Okay, we're good. Hey everybody, thanks for coming to my talk. That tiny URL gets you these slides. I highly recommend grabbing them because I have a lot of slides and I talk very fast. And I only have 45-ish minutes, but there's nothing after me, so we'll take 3 hours. Let's just have fun. Hey, we know that we keep getting attacked, right? There's a class of attack that I think I like to call it and refer to it as, and we keep seeing it out in the ether out there as identity-based attacks. Is that better? All right, cool, we'll get there. All right, identity-based attacks, meaning I have logged in as somebody else or as something else and assumed its identity in order to pull something off. This is kind of the last step on a lot of the attacks we've seen recently, both on the human side where people are just going in and changing admin. This is from May. I'm not picking on WordPress here. WordPress is picking on itself. You can just go in and just reset admin passwords through this plugin that they sell. This was a sold product that will let you just reset all the credentials. But we also see people logging in as if they were machines and saying, hey, I am this API. I am the entity that's supposed to be calling this API, and I have a key for it, so you're going to let me in and do whatever I want, right? And there's some trickery in there of like how they go about getting those credentials and how they use them and what other exploits they pull off. But we can all agree it's just a giant dumpster fire out there, right? Like, we keep fighting this, and the longer I'm working in the security realm, the more I feel this is the most accurate slide I've ever made in my life. This is another slide that I use a lot. And this is, in my opinion, what good security actually looks like. This is the point. There's no fire going on. There's no emergency. This is a happy family playing an impossible game of Monopoly. Don't pay attention too close. Nobody has that many hotels playing in children. That's not the way Monopoly works. But other than that, in the staged photo, this is what we should be shooting for. If your goal in security is to be smarter than everyone else in the room, go make up word puzzles. Go create New York Times crosswords. Go do something else. If your goal is to get to here, then you're doing it right. At least in my opinion. I'm Dwayne. I live in Chicago. Drove over for this. I rented a car to drive over for this. I host a podcast, the Security Repo Podcast. I highly recommend checking that out because we got awesome guests from all over the world on there. And I like talking about music. And I always say that I'm not really important. I'm just a message carrier in general. But I am important enough that I going to bed last night, found a USB key under my pillow. I don't know what that means. I've not plugged it in anywhere, but I'd like to plug in a random USB that someone left in my room and tell me what's on it. I'm going to leave it up here, and you can do that. But that's who I am. I work for this company, but they're not important. They will come up later. We know what attackers want. This isn't really hard to figure out. They want your machine resources. Why do they want your machine resources? Crypto. They want to do DDoS. They want to use it for their own nefarious purposes. And why do they want your data? Starts with an R. Yeah, ransomware. My favorite joke in security ever is how did the hacker avoid the FBI? He ransomware. It's terrible. When we think it's not my joke. I stole that. Actually, 3 years ago I stole that in October 2022 is when I first heard that joke. I can't remember who said it, but it was at Secure WV. Anyway, back on it. I want to talk about secrets. There are two basic classes of secret, kind of like you can divide the entire world into everything in the entire universe is this microphone and not this microphone. We can define the entire world into humans and not humans. I am not going to explain humans to you. Hopefully we all know what humans are. The non-humans, though, that takes definition because it's so broad. A definition that I'm going to go with is OWASP because I love OWASP. Any OWASP members in the room? Oh, you should all be joining OWASP. OWASP is awesome. And they would welcome you and they would love you there. And to have those conversations out in their messaging and their events. But they are defined non-human identity as software in an environment that runs in a larger system and it connects through using secrets. That's very broad. I like the term workload identity a lot more, and I like machine identity a lot more. And I actually really like workload identity because the IETF has defined it. And this is an ongoing conversation. We're on draft 4, or I think we're almost to draft 5 of the Whimsy standard, which I'll talk about later. But it's a running piece of software that executes for a purpose. I love that. That is simple, and it's a very broad category, but it's a pretty simple idea. So why I focus on the machine part of it is that there's just more surface area. There's only so many humans. There are infinite, it feels like an infinite number of machines. In 2022, CyberArk said there are 45 to 1, which looks like that. I don't think that's accurate in 2025. I think it's closer to 100 to 1. There's one report that says 144 to 1 now, thanks to agentic AI. I don't know. All I know is the future is going to look like this. I don't know how many's up there, and I don't ask anyone to count. I never counted it. But the future's coming very, very quickly, and we have to get a handle on identity access management for this now, and this is the battle cry on the hill I'm willing to die on. None of the other stuff matters. Like the endpoint, we've watched so many attacks recently, like the NX singularity attack, the Shai-Hulud. The whole point of that was to dump credentials. What do they do with credentials? Well, go ask Red Hat what they do with credentials. Go ask their customers, and that giant, why they're going to see a giant spank in ransomware this year is directly because people left credentials for all of these things in their code, and then it got dumped. This is what we keep doing. As I say credentials, secrets, I use these terms interchangeably because I just do. They're the same word in my head. I know semantically a key is not the same as a database connection URL, but they're both things that shouldn't be shared that grant access to another system. And that's the core of the problem. Once you have the key, I have a whole other talk called I'm a Machine and You Should Trust Me, based on the fact that we're not asking who are you, we're asking does this key work, and then it lets you in. And it's a problem, and it's a growing problem. So my company, GitGuardian, I knew they would come up later, they do a report every year, and we look at how we build the report is, in fact, why we do this, but we look at every single commit that hits GitHub public. Everything that becomes public on GitHub. You can as well if you would like to, api.github.com/events. It's a feed. It's a fire hose. It's 1.4 billion events last year. And we look at all of them. And if it contains a secret, we email the person immediately and say, hey, you did this in public, committer ID, or committer email, because thank goodness Linus needed to organize people by email so we actually know an email address for a Git commit. Never forget that Git came out of Linus Torvald literally managing patch and diff on his machine. That's where it comes from. Like, Git is a human level conversation. So luckily, we have to have that human level conversation with an email. Hopefully it's going to a human. So this is for the money. Don't look at the report. If you've already looked at the report and you already know these numbers, you can't answer. But this is for an actual prize, a handmade prize that I made. And we'll do closest without going over prices, right? Rules, and I need hands. How many secrets do you think we saw added to GitHub public in the year 2024? And if you know the answer, don't answer. 2 million? 2,000,001. That's a very hacker answer. Currently, accounts, there's over 100 million users. There are 680 million projects, roughly, but only 64 million got updated last year. 24. How many? I can't do math, man. Like, if you're like me, you're drunk. No, kidding. I'm kidding. I'm hungover. 12 million? All right, another number? Any others? 5 million? All right, the answer is actually this number, 24. And here's your prize. It's a handmade octopus. Get it later. I ain't got time for that. We'll figure it out later. It's a handmade octopus I crochet. But I'm sorry, I misquoted. It was 69.6 million public repos got updated last year, 4.6%. So 5% is actually pretty close. Divided by 5, no, 5% is close. But yeah, that's terrifying, right? That's 25% increase over the previous year using the exact same methodology. When we first did this report in 2020, before I worked for the company, the answer was just over 2 million, 2.3 million. Different methodology, sure, but we have seen a 10x increase year over year. This isn't cumulative. That's per every single year. 15% of all commit authors leaked a secret last year. Internally, we know this is 8 times worse. Literally what my company does, we built these amazing scanners to scan public internet, but also, why can't we connect that to internal stuff? This isn't a sales pitch, but when we do connect it to internal repos, it's 8 times worse because people have the illusion like, oh, it's an internal system. Who's going to see this? I'll just hard code the secret here. And then things like, I don't know, leaks happen or breaches happen, and like kid gets into Uber's internal system, finds PowerShell scripts completely chock full of credentials, and pwns HackerOne from within their own interface in 2022. That's one of my favorite stories. It's one of my favorite stats, but one of the scarier stats up here is, so we have a database of these credentials. We know what they are. We've been doing this for years, since 2017. So we went back to 2022 data and said, okay, here's 11,000 credentials that in 2022 were valid. We did a non-intrusive call to the system they're connected to. They were valid. They came back. We retested them in January of 2025. 70% still came back as valid. Yeah. This is Verizon's DBIR. Who reads the Verizon DBIR every year? The Data Breach Investigation Report is one of the best free publications on earth. Go read it. It's lengthy, but it's so good. It's written by humans for humans. They even have an ignore previous instructions paragraph in it this year as a joke, but specifically to call out that this is not AI generated. Some of the images may be a little fudged by designers, but still. Credential abuse, that's the way we're getting in, and this is only going to go up. We're only going to see that go up. As phishing gets less effective, as we figure out patching a little bit better. But why would I bother learning how to hack a 0-day when I could just get your credentials and walk in? Like, why? If I'm going to attack your web infrastructure, I'm not going to phish you. I don't think you have your database credentials. I believe your database credentials are probably in a Jira ticket, though. And if I get into Jira, I could probably find it because you were working on that database, right? Nobody's done that, right? You've never helped the next person in line by hard coding something into a ticket, right? Ever? The average they found was 94 days after they know about the breach before it gets rotated. We asked people in our report with CyberArk, we did this report last year, and I love these numbers because they don't make any sense. The more you look at it, the less it makes sense. 75% of respondents think they've got this under control. And the same exact people said 40% of developers, only 44% of our developers follow our procedures. And we think it's 27 days for remediation. That's not true. We know for a fact that's not true. This last one's very interesting, but that's a whole other matter, is how many secret managers do you have? The fact they said 6, I once had someone from an insurance company laugh at me out loud when I said that. It's like, dude, maybe 6 per team is what he said. The secret vault sprawl is very real and causing confusion. So what do? Well, if we ask Google, this is my favorite Google developer doc of all time. That's the entirety of it. It fits in one screenshot. Yeah, just change the secret and re-architect. That's all you got to do. It's that simple. It's like the secret of flying. Just don't fall down. It's that easy. So what do we actually do? Let's be serious. Well, if we're humans, we have these paths that we can go down. And if we're not humans, well, there's a whole other different set of concerns. Because humans, please move to passkeys. Please embrace FRI-T2. Please use WebAuthn. On one of my other screens, I'm reading the WebAuthn standards right now. Oh, reset to the top. I'm going to have to find my place in this again. I was halfway through. Oh, no. Anyway, go put WebAuthn everywhere you can. It makes sense. Humans are good at this, or we should be good at this by now. Get rid of your passwords. Oh, there we go. If you can put it to a role, put it to a role. There's a lot of things that makes sense for. You can just assign some kind of IAM role to. AWS makes that pretty straightforward. But let's be honest, what we get stuck with a lot is these long-lived credentials that are over-permissioned, and that's the easiest path that developers have had for years, is just put a credential in place. Let's put a secret in place. Let's hard-code it. So what we can do is start encouraging faster rotation. But the problem is if we just rotate and don't re-architect, because that Google Doc is not wrong. If we don't change our apps, this is all we do. and we just reset the clock. It's like, how long till the breach? How long till someone finds this secret? How long till someone finds this secret? Now, if you changed this out every single day or every 15 minutes, yeah, you shorten that attack window, but wow, changing code and getting those pushes through in an actual environment, that ain't gonna happen. So what do? Well, I think any good plan, and I say secret management, this could be any plan in the world, really is these three areas, these three overlapping concerns that I think make a virtuous circle, but it goes counterclockwise. And I keep meaning to change it, but I kind of like the fact it's counterclockwise. But you're all in this room to raise awareness, and I'm getting to raise awareness with you right now, and hopefully you'll go back to your teams and raise the same level of awareness and start talking about some of the solutions I'll get to in the second half of this. But then start documenting and creating processes around, like, how do we actually do this? Tooling should be your last choice. You probably already have the tools in-house. This is not a vendor pitch. This is literally, please go talk to your teams and figure out what tools you've already purchased and how to better apply those and train your teams on them and raise awareness that we need to better use them and create better processes and better documentation to figure out how to automate those tools, and then fill the tool gap. Obviously, if you're missing a tool, get a tool. But we have to figure out who owns this. Does security own this? Maybe. They're the ones that go in front of tribunals if things go wrong, if they're the ones that almost go to jail repeatedly. Why is it the IAM owner? The IAM owner is supposed to own all of your identities, right? They're the people that literally are in charge of identity access management. And if these non-human identities are also identities, why not them? Well, probably your company's too small. Unless your company's over $5 billion in revenue, you probably don't have this person as a dedicated person who reports to the CISO or the board. I don't know why not, but I think it needs done. But that's like asking like, who owns Active Directory? It should be the same person, but who owns Active Directory? It's that, who owns that level of identity? Who owns the risk here? Everyone does. That's the horrifying truth. I wrote a paper recently on ownership. And I thought I understood ownership going into writing that. I honestly thought I did. But have you ever stopped to think about ownership in the corporate setting? Like, ownership on a personal level is pretty straightforward. I own my shirt. Like, I can do anything I want with this shirt, and it's mine. And I'm responsible. If I leave it and somebody trips over it, it's my responsibility. But who owns your instance of Jira? That's one system, but that's a very, unwind that complicated system. Who actually is in charge of it? Who administers it? Who's in charge of the governance for it? Who gets called if it goes offline? Ownership inside of an organization is a basket of responsibilities that's contextually dependent on the set of circumstances when you talk about ownership. That's complex, but it means we all need to be on the same page. Everyone sees risks very differently. I love Walt Powell. I love this quote because it's very true. We keep talking about risks as if everybody else knows what we're talking about, because we in our brains say risk is this, and I'm not saying this is wrong. This is totally true. But that's how we see it. Everyone else on that earlier slide sees risk a little bit differently from their perspective. Developers see it as, does this go to production? Does this keep it up and running? Do I meet the ticket? Do I hit the deadline? Can I go home and play Monopoly with my family? Your DevOps team sees, hey, is this thing up and running? What's the metrics? Do we get observability into here? Can we respond to an incident? Are we losing money? I'm not going to explain the CISO role to you. There was a panel on that just a little bit ago. Exec team, hey, is the business making money? Are we overall successful? Are we paying back the investors fast enough? I don't know what the IAM person's thinking, but they have their own set of concerns. We got to get everybody on the same submarine, is my point. I know what you're thinking. What submarine? Good question. One of my favorite books of all time is You Can't Teach a Kid to Ride a Bike at a Seminar. It's a book about sales. And inside this book, he lays out the Sandler submarine. This is how you sell things. This is still true. This is awesome. This is a great way to work with enterprise sales. So I'm using and selling this model, or borrowing this model. So how this model works is you move from the front of the sub to the back. All submarines built before 1976 worked the same general way. You sealed off that compartment, and then the boat didn't sink if there's a hull breach. Pretty straightforward. So you seal from front going back, and you don't look back. You seal it off and you keep moving. So our plan should be something like this. I'll just move on. You find all the secrets, properly store them, give developers better tooling. This is the crux of the entire thing in the middle. It's very important, otherwise the whole thing sinks. And you keep scanning, and you automatically rotate secrets. So fortunately, this is a pretty well-established pattern. I'm going to go really quick through the next 3 slides because I really want to talk about the other alternatives. Well, finding all the secrets. If we don't know it's there, we can't protect it. We can't do anything about it. So it's like any other part of threat modeling, we have to take a full inventory. And everybody's keeping track of all these secrets, right? Like they all know all the API keys they've assigned, and like all your developers got them somewhere, right? You can just go to the IAM or to the infrastructure team and say, hey DevOps, what are all the secrets you got out there? They got those in a list, right? No, it's silly. Hopefully they're somewhere safe, but we know for a fact, based on what I do for a living and where I work, they're not. They're everywhere. They're not just in code. We focus on code a lot, and code is very, very, very chock full of secrets, but we find secrets in Jira, Slack, basically any system you hook up to our scanners, we find secrets in. It's kind of terrifying. But it's everything around. It's only 8% overlap. That's what we've seen, 7 to 8% overlap of secrets that are in these other systems are also in code. So it's a whole other set of concerns. They're probably properly stored credentials somewhere that someone copied into another system, again, to help the next person out or to make it quicker to move it across the wire or something. I don't know. There are plenty of tools that can help you with this. I have a personal favorite on this list for many reasons, but we don't need to get into that. You can even do this locally with grep. GitGrep is awesome if you really, really want to like build your own. I wouldn't recommend that. There are open source alternatives before you should build your own, but go and find these secrets where they live. There's many options, and I'm happy to go in great detail about how we built our detectors and the ML behind it and all that good stuff. But that's going to get your baseline. We know where these secrets are now, where they're not supposed to be. So what do? We properly store them. And this is a very highly accurate diagram of how secret managers work. I spent days on this thinking through the color scheme, because I'm a designer, obviously. No, they all work the same. You store the secret at rest encrypted and very safe vaulted, and then you call it into wherever you need it at runtime in a safe way over a path. Hopefully you're doing that over MTLS, hopefully. And hopefully it is not just dumping it in memory and then just leaving it in a variable forever. Otherwise we get things like, supply chain attacks. Anyway. Yeah, this is all I just said. Central reporting is super actually important because if you don't know what's in there, you don't know how it's being used, then you end up with zombies and things that shouldn't be in there that are still living, but they should have been decommissioned by now. But if you don't have that observability in the system, you're never going to know. These are on all the major platforms. Your team has no excuse not to use these. These are awesome. AWS has secrets everywhere, or secrets anywhere, which will let you use their secret manager across systems. I've heard mixed reviews on that, but I think it's all in the implementation. The devil's in the details. And if you're in multi-cloud, on-prem, hybrid situations, you're just going to need a platform that can handle that situation. There's plenty of vendors out there. I sound like I work for CyberArk half the time because I cite their metrics and reports and we work with them, but they all do the same basic function. Store it at rest, let you call a path in to get to the secret. This is what Vault, just pay attention to the first lines. The rest is just their example on proving the path works. Don't actually ever write this. Would not recommend, because that's dumping the credential. That's literally how you dump the credential. But how do we get this into the code in place of where the secret is? Well, actually, there's a really good talk about specifically that from B-Sides Las Vegas last year, not this year, but previous year. Kenton, really cool guy, but he gave a really good talk on how he does that for satellites. If you update a satellite in space, you get one chance. If you get it wrong, you cannot do it again, because you got one chance. So that's how he does his blue-green deployments that you can roll back on a satellite. It's like, that didn't work. Okay, go back to the previous wonderful state. So he can talk to you about that. And then do this for your new projects, especially, like get them in the vault. Then go after production and say, hey, make sure everything is properly vaulted. This is 2025. I think we should be already there. This is the hard part. This is the hard part. Not that you bought the tool, great. You want people to use the tool, great, but how do you get them to use it? This doesn't have a simple answer. How do we get them better developer tooling? Developers just want to go fast. They want to get the ticket closed, they want to go home to their families, eat dinner, and not sit there and bang their head against the keyboard and say, wow, this ticket came back yet again. I've never met a developer who likes Sneak, and I'm not picking on Sneak, but I've never met a developer who liked them because it's a lot of loud alarm bells in their IDE. And it's like, I don't care about that large alarm bell. I don't care. I don't know what a CVSS is. I just want this to go to production. Makes them go slow. We need tools that make you go fast, give you the better solution inside the tools you're already working. And I think that's the role of security engineers. I talk to enough of them to say, yes, I've met these people that do sit with developers and look at their workflows and say, hey, how you doing? What are you working on? Oh, why are you doing it that way? Oh, that's the easy way? Let's make that the dumb way. And let's make this other better path, the easier path, the safest path. These people exist. The magical language we can all speak is Git. It's not a language, but wow, what a communication mechanism. All developers speak this. All developers use it, or 97.8% of them anyway. Maybe they're on SVN, I don't know them. But why not sit with them and say, hey, let's build a Git hook for you that makes sure you don't hard code secrets anymore. This is explaining a script that I have seen in production actually used. Hey, let's find the secret before you make the commit. When you go to try to make the commit, find the secret, stop the commit from happening, but then let's go look in the vault, see if the secret already exists in a vault, pull it back, give me the path for that, and then let's replace the secret you were trying to hard code with the path. If it doesn't exist, let's push it to a vault and then bring that path back. And then hopefully every time you are submitting a new path and it checks out and yeah, that secret works and it passed the test, there's an automatic rotation on the back end. This isn't out of the box. This isn't a tool I can magically sell you. I wish I could. This is work. This is the work we should be doing and focusing on, like how do we get developers to this? We built a reference implementation for exactly what I just described. We called it Brimstone. We did it with CyberArk, but we're able to do this with pretty much all the providers right now. But we're happy to tell you how to do it. It's just a matter of work. Then, of course, people are going to be people, so keep scanning. But it's important to bring that up because people are still going to get around your system. So continually scan because people are going to be people. Then automatic rotation. Here in 2025, this shouldn't be a magic trick. In fact, all you need is write a script that does this. Create a new secret, swap it in, test to make sure it worked, and clean up after yourself. Where that logic came from is literally out of AWS's scripts they've already written for you to do automatic rotation within their secret manager. This should be the easiest part. The hard part is getting the developers to use it, to get that in there. This is the crux. This is after 3 years of giving similar talks. This is finally the point where I'm like, this should be the easy part. It's getting them in there and doing the rotations. Getting them in there in the first place and getting developers to actually make the proper calls is the hardest part. The actual rotation, there's plenty of blog posts. I'm not going to bore you. I used to give a whole talk about the ins and outs of it, but honestly, go talk to your Vault vendors. They already know how to do this. They know how to do this better than your team because they do it day in and day out and they breathe this stuff. If you're using systems that you can't hit an endpoint to invalidate a secret and create a new one, get another system. Again, it's 2025. Your API should be able to provide this level of service for you. Or we say, wow, that's going to be a lot of work and that's going to be really bad. And basically all we're doing is kicking the can down the road because what if someone gets this key to the vault? What if they get the base level secret? If we keep abstracting secrets out, what happens if someone gets that other secret and we keep going down that hole? The reason I want to give this talk and the reason I'm on stage these days is this. I want the entire world to embrace better workload identity. Raise your hand if you've ever heard or you know about Spiffy. I want every hand in the room to go up, and you will after this. Thank you for being here. Spiffy is the secure production identity framework for everyone. It's been around for 8 years, people. It came out of conversations inside of Google and Netflix. People with actual production needs. Google engineers, I talked to a Google internal engineer, like a low-level person, beside Seattle. I was like, so how do you deal with key management? I didn't know where she worked. It's like, how do you deal with key management? She's like, what do you mean key management? I'm like, how your machines talk to each other. Like, what are you talking about? And finally, I figured out she works at Google, and instead of long-lived credentials, what they do is they issue things, IDs, cryptographic IDs, when they're born, that are run through a certificate authority. So when a service comes online for the first time, we know through trusted boot or verify, what's that called? Trusted verified, my mind's blanking. But we know through these verified paths that, yeah, this is the IP address, these are the hashes, these are the things we expect. We can prove this is the thing of time of creation. Because of that, we can trust it enough to give it a certificate that says, hey, this is the thing. It can exchange that token at any time through the provided service to get a short-lived JOT or X509 or some kind of short-lived workload token to say, let me do my work. And then it expires in 15 minutes, 15 seconds, a day, however long it takes to expire. So if I'm an attacker and I hijack your pipeline and I get one of these, I have that long to exploit it. Not a month where I can sit back and figure out how to write a prompt injection that gave us NX and Shai Hulud. That's what happened. They attacked a pipeline that was AI optimized, found a flaw, found a way to dump a credential that didn't get rotated for a month. The next move was inject prompts that 2.5 million downloads happened on that said dump all your local credentials and give them to me in a public dump that's double base 64 encoded. Now, the good news is on the first pass, they only got $500 in total stolen Bitcoin, or crypto. The bad news is they figured out how to make it into a worm and relaunched it as Shai Hulud. And there's no exact direct evidence that Shiny Hunter, whatever they're calling themselves now, what's the full name? It's something stupid. Shiny Lapsus Hunters. I love these ransomware names. There's no proof that they are the ones behind it, but did they use the credentials stolen to get into, I don't know, a very large company owned by IBM? Maybe. That's a pretty probable way we got to the situation we're in now. That's freaking me out, to be honest, way more than it should. Anyway, there's a whole book about Spiffy you can get into. And if you're like, hey, wait a minute, aren't you just describing OAuth? Yeah, this is OAuth 2, but for machines. This is what 2.1 is going to have in it. Or be addressing better. There's a whole book about this. I highly, highly, highly recommend spiffy.io/book. There's a whole part of it that explains how you're going to save your developers like 5 hours a week by not having to deal with permissions and secrets in general, by sidestepping that entire issue by using namespacing and allow listing, basically. That's an oversimplification. Go read the book. And if you're like, I don't want to read a 198-page book, which I understand, there's an entire awesome talk from people that wrote that book, or some of the people that wrote that book, that I link in here, and it uses cute images that are definitely not Disney properties. These are AI, completely not Disney properties that they used to tell the story. But you're like, wow, that's cloud native, sure. Okay, cloud native's always like 5 years ahead of the curve anyway. Whimsy. I mentioned it earlier, but the workload identity for multi-system environments is a standard that is coming out right now from the IETF, the Internet Engineering Task Force, the people that make HTTP and TCP and IP and all the standards that the internet is based on. We agreed these are the protocols we do, and that's called the internet. They're working on this. Same exact idea. Like, how do we build workload identities in place? They're on draft 4, or I think we might be on draft 5 by now. But there's ongoing conversations. There are emails every day on this that are arguing what is even the definition of a workload. That's where this came from. But now there's a whole argument about, is this too generic or is this too specific? It's happening in real time, and you can go join the story if you want. You're like, okay, that's great, but that's still coming. That's like a revision on a RFC. But this is actually live now in Kubernetes, and it has been since May. This idea of workload identity is how you can do image pulls in Kubernetes as of 1.33. This got buried in release notes, and I don't even remember how I caught wind of it. I think one of our engineers inside my company was like, hey, look at this cool thing, because they knew I was talking about Spiffy and workload identity. Developers don't know this, though. I have yet to meet someone that's actually deployed this in the wild. So this is my challenge to you. Go back to your teams, like, hey, you guys use Kubernetes, right? You know there's a better, more secure way to do image pulls? Because Kubernetes isn't getting attacked, right? You're not here to secure Kubernetes, I know. But if you are, go have this conversation with them. It's like, hey, are you using like short-lived automatically rotated tokens? Because you've had since May to put it in, and I know that's not your focus. Your focus is to keep it up and running, but we can keep it up and running longer if we move to these better systems. Oh, and by the way, every platform on Earth supports this already. This isn't the future. This is months ago these blog posts were written, or these documents were updated. So you want to federate your identities? Yeah, you can do this now. There's guides. There are companies that focus on this. They're like, I don't want to do this on my own. I don't want to be, because nothing's free. There's engineering time this takes. This is a project. This is going to take a lot of work to move to these systems and to rethink the way that we have done authentication for machine identities. But we really can't get there until we do these steps. Without that first step of understanding your inventory of what you're even trying to replace, what are you doing? Sure, for greenfield projects, we can restart out. For new Kubernetes projects, sure. That's not how the business is making most of its money. If we're aligning ourselves with the business needs, look at how the business is actually running, and it's not rip and replace. It is, how do we modify this ship that is already sailing that pays our bills? Agentic AI is going to make this so much worse. So much worse. The fact that we're training the AI on stuff that's full of credentials is part of the problem. But we're now seeing credential leaks out of the logs from trying to train RAG models. As long as we keep using hard-coded, long-lived credentials to do authentication for machines, remember, machines do not have fingerprints. Machines can't hit a point of like, I can't do my job. Let me go get a better level of access. Let me go bother my IAM person so I can get a better role. They'll just fail or they work. And so we overprivilege them because we just need them to work. Because again, we need to make money. We're a business. AI is going to exploit that harder and faster than humans ever have. And AI is deploying AI now, which is terrifying, to be quite honest, from pure energy perspective. But the inherited rights it got at the beginning of that chain of agentic chained agents is going to pass on to all of it, the way we build it right now. Or we start tying this down, and I don't have a good answer on how do we do that. I wish I did. But I do know that I don't want to think about that 24/7. I do know that I want to go home and do stuff that I want to do with my family and the people I love. And I don't have to keep talking about long-lived credentials long into the future. Thank you very much. I was just saying thank you for him giving me a 5-minute warning, but I'll take the applause. But I was actually done. I'm here. I live in Chicago. Check out the Security Repo podcast. We have awesome guests, and I love talking about music. I didn't go to the show last night. The Death Haven was in town. I didn't go to the show. I really wish I had, but I didn't find out about it till late. And it was, anyway, didn't even sell out. I was sad. But I work at GitGuardian. We focus on finding the secrets, and then once you have them in the right place, putting the observability around it to figure out, do we have policies that actually govern this stuff at scale? But that's why I'm interested in this stuff so much professionally. And again, there's where the slides are, that tiny URL. Please get them because there's links down in there. And for the first time ever, I actually have time for a question or two. This is like weird. Normally I go right up to the line, so I spoke fast. So thank you very much. Yeah, you can applaud again. Here. He had put his hand up first. Oh, yeah. Oh, so the question is federated identity in the hardware world. How do you implement that? And I don't have a good answer there. That would take some research. I'll admit this is one of the flaws of being like AppSec Village. I'm one of the organizers for AppSec Village. I don't have that on the slide, but one of the flaws of being application security focused is that you forget hardware exists sometimes, and I don't know the answer, unfortunately. But if anybody else does, please, and we can research that. I'd love to research that actually. Oh, the question was how can you do something like Whimsy or this certificate, this federated identity where you're issuing a certificate at birth to actual piece of physical hardware for embedded systems, for operational technology. Yeah. There's got to be an answer to that. I just don't know what it is, unfortunately. Oh, it wasn't NASA. The Visistat is the company. That's Kenton. But yeah, anyway. Yeah. Him. Oh, firmware. Yeah. So I understand the question, but when I say one chance, it's like there's one pass and they're pushing it up there. So he's doing blue-green deployments. That's what this entire talk is. So blue-green deployments for that. But software, we have to cryptographically prove it's the thing. Hardware, we can read the MAC address and we can see the other identifiers on to say, I trust this is the thing. That software doesn't have those physical traits. That's the key differentiator. So like this machine, inside of it has serial numbers and ports and like very specific numbers etched into the actual machine and like the hardware itself. I don't understand that part of the world, unfortunately. Any other questions? All right, in the back. Oh, well, when the attacker gets this vault call, they have to be, like, the way that reason it's there is the attacker sees that, and that's what they get if there's a leak or they get a breach in. They would have to physically run in the same environment that is authenticated against that vault to be able to call that. It's not impossible, but it is way harder than, oh, there's the database connection URL. There's a vault call. But this is literally why they called it solving the bottom turtle. Is you're right. This is just vaults are just an abstraction away from hard coding the credential. And sure, we can abstract that key down farther and farther, but it's turtles all the way down. It's keys all the way down unless we move to systems that aren't keys. They're different ways to authenticate. All right. Well, thank you very, very much. We are at time. Thank you.